Hello, and welcome to a special episode of the Arm Viewpoints podcast. I'm Brian Fuller, editor-in-chief at Arm, and today we're sharing the second of our two-part conversation involving Charlie Blackwall, head of electronics for the Aston Martin Aramco Formula 1 team, and John Kourentis, Arm's director of automotive go-to-market. It's excerpted from a fireside chat the two held in Cambridge this summer. In episode 1, they discuss the partnership and the amazing technology that, pardon the pun, drives Formula One racing today. In this episode, they discuss Aston Martin's new state-of-the-art wind tunnel and why owning it matters, how Arm's ecosystem accelerates innovation, virtual first workflows to prototype models and hardware in the cloud before landing on the car, and what the future holds for a sport that's increasingly embracing electronics and software. Let's listen in to part 2.
Another big change recently has been the introduction of the wind tunnel.
Yes. So previously we bought time from Mercedes to use their wind tunnel, but we know that to win a world championship, we need our own. So we've built this amazing new facility, and it, as you said, it's the most advanced wind tunnel in the world. It does everything. It's really, really impressive. But the key to that is, how do we use it? How do we get the data off it? How do we analyze all of that data, and how do we best correlate it all as quickly as possible? Because we're limited on how much we're allowed to use the wind tunnel by the FIA as well.
Yeah. But let's dig into that in a bit more detail. So we've got, as I said on there, so we've got a 40% scale of the
6%.
What's kind of inside that?
So if you looked at it, it would just look like an F1 car, but 6%. But underneath it, it's very, very different. So there's obviously effectively an industrial system, but it's all miniaturized. So everywhere on the car, there's pressure tapping. So we're trying to understand the flow around and the flow around the car, because trying to work out what the load is. So you've got, it's fully active. So you've got active suspension. You can change the ride height, the pitch, the yaw, everything. And that's all controlled. And what we're trying to do is we're trying to move the car in the airflow and see how it reacts, see what the load change is. But with that as well, as I said, there's pressure tappings all on the wings, on the floor, along the top. But then there's also the PIV system, which I can't remember, particle velocity inference or something like that. And that's what we do is you visualize the flow by firing tight, like microscopic oil droplets over it, and then you fire lasers through it to then visualize what the flow of air is doing over the car. And that is the real technology. That's the really exciting bit. So those things combined give you all of your correlation to understand, has this new front wing brought performance improvement, or is it doing what we expect, which is the main thing. It's about correlation with the CFD models.
And what difference does it make having your own facility versus when you were sharing a facility with the Mercedes team?
Well, it's all about speed. We have full control of it. We have full control of how we operate the system, the interface between how the wind tunnel is controlled and how the model's controlled, and how we control all the data as well. So we have full control of it. And the other thing is that we can react more quickly. So with Mercedes, we had to use it when they weren't using it. Whereas now we can do it when we need to do it, when we want to do it. And again, we develop all of the sensor tests, all of the technology around it. Yeah. So it's just a massive step up.
I assume there's no love lost there between teams as well. So they're not doing you any favours when they're giving you the wind tunnel time, right? Okay. And do you? So that's largely looking at the development of the 2026 car, I guess.
Yes,
that wind tunnel time.
When we commissioned the wind tunnel, obviously we did a sort of a back-to-back correlation with the existing one, and we were allowed to do that from the FIA to try and make sure that it was operating how we thought it was. So that'll happen. We've done a little bit of AMR 25 running, but it's predominantly AMR 26. It's all focused on next year.
So looking forward to big leaps forward next year, and culmination of a lot of hard work between the teams. If you had to sum up from we're kind of 8 months since we announced the partnership. We've been working together obviously for a bit longer than that. If you had to kind of sum up the partnership with the Arm team for you and the team around you, how would you kind of do that in a sentence?
It's exciting because it's bringing in new ideas. Yeah. It's bringing in new ideas, and it's increasing the speed at which we can react. So the example of this is, I want to bring in new technology. At the moment, I'd then say to one of my engineers, can you have a look at this? They'd do a load of research, then they would, few months later go, I've got a framework, something I want to do now. We don't do that. I can just speak to you and you go, we'll do it like this. Or here's an idea. And then suddenly you streamline that process of introduction of new technology and also the new ideas as well. Here's something, have you used this before? What's that? This is really cool.
And the interesting thing is, we're fortunate at Arm, we've got this rich ecosystem, all you partners around us. And so we have visibility of a lot of the cutting edge technology that's in development or that's just recently landed. And so we're able to kind of cherry pick a lot of the best ideas from everything that's happening in the ecosystem. So actually, everyone in this room is kind of contributing to the success of this partnership, right? We're drawing on that expertise that's being delivered from the whole ecosystem and guiding us, Aston Martin, as to where they should be looking, because you're looking for parts that are on the market available today, right? This isn't kind of future roadmap technology. This is all, the here and now, what's available today. And that's all comes from the richness of the ecosystem that we have around us. So everyone here is contributing to the
I mean, something that we discussed last time, which was, again, about streamlining and bringing things to the car quicker, was about how we can do everything in a virtual environment.
Yeah.
So, for instance, when we want to talk about putting our machine learning model on the car, not only can we develop all the model and run it in the cloud, we can also develop the hardware in the cloud and simulate all of that in the cloud. So we can just go, right, that's all done. Now we can make it, send it onto the car, and then it's done. And it streamlines that process and brings things to the car quicker.
Just to wrap up, any thoughts on the future of the partnership?
Oh, it's exciting. I'm looking forward to getting, to taking us to the next step. In electronics, as I said before, we can be quite cautious and not trying to take too many steps or not jump too far. But I think now we can, and now we can bring these new ideas in and actually sort of exploit where we can find ways to make the car go faster, get new data, put instrumentation, but then also the sort of off-car AI sort of style of stuff as well.
Fantastic. So just to wrap up, what's really interesting, very, very different environments, right? Race car environment versus passenger vehicles that we're generally working in, but the trends are really, really similar. Actually, what you're seeing is the exploitation of AI in race car, in their strategies, in their off-board systems. And it's very, very similar to actually what we see happening, the transition that we see happening in passenger vehicles, right? Passenger vehicle platforms, moving to, single function ECUs to more consolidated compute platforms that are being defined by software, now very, very quickly shift into how you can leverage AI as quickly as possible in those systems. So very different environments, very different scale, but very, very similar trends that we see happening across the F1 relationship that we've got with Aston Martin and what we see happening in the broader commercial industry as well. So with that, Charlie, thank you very much. I really appreciate you taking the time to come and share your thoughts and experiences with everyone here. We've got a few minutes for questions, 5 minutes for questions. So if anyone has any questions, feel free. We have one at the back there.
Thank you for the great talk. I did have a question. I imagine while the vehicles are running, there's probably bandwidth limitations for like telemetry and various things like that as it's going around a track. It's moving to more software-defined vehicles. Does that make it easier to actually make changes or like evolve your plans where you don't have to worry about connection speed and it's just doing it on its own?
I think in Formula One, we're restricted on what we're allowed to do. So the telemetry system is provided to us by Formula One management. We have to use it, and we're not allowed to do anything outside of that at a race event. But in terms of off-car, so in the wind tunnel, in our test rigs and so on, we can do whatever we like. So yeah, having more capable systems certainly improves that. And again, it's about getting quicker, more data more quickly and then being able to correlate it more quickly. So that link between sort of CFD and wind tunnel is the key. So, getting that, the sort of getting the CFD models, getting that data, getting the wind tunnel model, getting that data, bringing it together and seeing where the differences are and doing that more quickly is going to bring parts of the car more quickly.
And I guess having a more centralized compute, not having all the intelligence in the sensor necessarily, but having a more centralized compute allows you to do kind of software on that compute platform without having to
just take the data from there and then actually centralize it and compare it in a central location.
Yeah, thanks. Great question. Angela?
Thank you for the talk. I start to learn a lot more about Formula One now, especially the movie just came out. So one thing is that besides the improvement of car, do you see like racetrack having sensors more so that you can really test the corners of the racetrack to improve your performance? Like besides a car, do you see like other sites improving, more intelligent, adding more AI stuff in there?
I don't think so. A racetrack is just provided to us by whichever country has one. I think the sort of area which is more interesting on that is how we do driver-in-a-loop simulators. One of the sort of key development areas for us is obviously we have a model of the car, a software model of it that we run. There's a driver-in-a-loop simulator. What we do is we scan circuits and then we try and make a representation of those, and then we drive the car around it in a virtual environment. That is an amazing tool that we use for car setup and car development. But that all hinges around understanding how the car works and understanding what the racetrack actually is. So there's very small subtleties in like how rough the surface is makes a big impact on the tyre model and all that sort of thing. So that's kind of where we would look at that.
Thanks, great talk. Most of the driver assistance systems that most of the people in this room design are actually banned by the FIA.
Yes.
But many of them are allowed, and I'm thinking of clutch point detectors, engine management, brake point balancing, that kind of thing.
Yeah.
Can you speak to any innovation that's happening for driver assistance in-car systems that is allowed by the FIA?
So I think it's interesting where you draw the line on what a driver assistance system is. Obviously, the car is effectively automated in terms of how it operates. So the whole hybrid power unit is automated. The driver doesn't do anything. He just has a torque demand. If you look at the torque controller, it's an analog sensor that goes into a torque controller, and then the power unit delivers it. The gearbox is fully automated. He just requests a gear change, and then we change gear in 0.07 seconds. And so in terms of the control system, there's an awful lot that we do. So like there's a thing called a clutch torque controller. So at race start, he just drops his paddle, I suppose, on the steering wheel. And then within our control system, we automatically operate the clutch to give the torque that he's demanded to get the best race start. So if it's driver demanded, then it's allowed. But if it's sort of things like collision avoidance, and we can't do torque vectoring and traction control and all of the safety stuff that we're not allowed to do, because it should be the driver driving the car solely and by himself, I think or by alone, I think is the regulation.
At that point, I think we have to wrap up. I think we're at time. So thank you very much for coming, and thank you, Charlie.
Thank you. It's been a pleasure.
For more information about how ARM's automotive technology and expertise are already driving the next generation of vehicles, head to arm.com/markets/automotive. Thanks for listening.